Here's a diagram of an atom. It's not perfectly accurate, but for what we need right now, it's going to do just fine. So in this lesson, we're going to look at characteristics that we can use to describe atoms like this one. You know, if somebody asked you to describe a person, chances are you'd use characteristics like the color of their hair, the color of their eyes, what their height is, and so forth. Just like that, there are characteristics we can use to describe atoms. The first of these characteristics, and maybe the most important, is the atomic number. The atomic number is often abbreviated by a capital letter Z. And what the atomic number is it's the number of protons in the nucleus of an atom. In my diagram here, I'm using these red circles to represent protons. So I have 1, 2, 3 protons in this atom. So the atomic number is going to be 3 for this atom here. Atomic number is particularly important because the number of protons in an atom tell us what kind of an atom it is. And by that I mean, is it a carbon atom? Is it an oxygen atom? Is it a sodium atom? We're going to talk more about that in the video on isotopes, so you don't have to worry about it for right now. The next important characteristic that we can use when describing atoms is the mass number, often abbreviated by an uppercase A here. Mass number is the number of protons plus the number of neutrons in the nucleus of an atom. People always get confused by mass number. Here's why. Atomic number is the number of protons. So everybody always wants mass number to be the number of neutrons, but it's not. It's the number of protons and neutrons. In fact, there's not really a name for the number of neutrons, just the number of neutrons in an atom. We just don't use it that often. So anyway, for mass number, we want to count all of these together. 1, 2, 3, 4, 5, 6, 7. The mass number of our atom here is going to be 7. Now finally, the third characteristic we're going to talk about here is probably the most complex, and that's called net charge. I don't have a good way to define net charge. I mean, I don't have a good definition. So what I'm going to say here is it's how protons and electrons balance each other out. Let's talk a little bit more about this. So net charge is about how protons and electrons balance each other out. So protons, as you know, have a positive charge, and electrons have a negative charge. So that means that if we have the same number of protons and electrons in an atom, like I have right here, 3 protons and 3 electrons, I'm not drawing the neutrons here because we're not worried about them. Here we have the same number of protons and electrons. They're going to balance each other out. This 3 minus is going to balance out the 3 positive, so we're going to end up with an atom that has a net charge of 0, because these two things balance out, and we can call this atom neutral, which means that it has no net charge.